thanks for clicking. Welcome to another Nargilus production. Today we're going to be talking about antiderivatives. So now it's time to go against the derivatives. It's time to go backward. So we've already learned how to go forward. That puts us at a huge advantage. You'll find out very quickly. But now it's time to go in reverse. So here we go. Let's see how this all works. So the concept here is pretty simple. Suppose I had some function and I know its derivative. Its derivative is equal to 2x. I want to know what f of x was. Well, I think you would pretty simply be able to figure out it's x squared, right? Because if I derive x squared, I get 2x. But it's not as simple as that, because it might not be x squared. And you might know what I'm saying right now, or you might be thinking, wait, what? It's x, the answer is x squared. Well, how about that? X squared plus 3. Could that be f of x? Well, what's the derivative of x squared plus 3? 2x. Well, now you're thinking, uh-oh. Because it could be that. Or it could be that. Or it could be that. It could be a lot of things. This is one possible answer, but these are also possible. And there are a lot of possible answers. So the question is, how do we deal with this? All right, so first things first. Let's talk a little bit about notation. Let's say I wanted to write if f prime was equal to 2x, then f of x is equal to x squared. Here's what I would write. I would write the following. And we're going to define all these terms in just a second. That's what we would write. That's how we would write if the derivative is 2x, the one before it is x squared. Okay? This sign here is called the integral sign. All right, or antiderivative. We're going backward. One step. Okay? And then this is what we would write to represent this process. All right, so let's talk about what all this stuff is here. So here's the notation. The integral of f of x dx is equal to capital F of x plus c. All right, so first things first. This sign is called the integral. The stuff inside of the integral, the function, is referred to as the integrand. The dx, which will be important, and you'll figure out why in a few minutes, we'll talk about it, is the variable of integration. Big F of x is the antiderivative. And the plus c is the constant of integration. Okay, plus c is the constant of integration. That plus c would be your plus 7, plus 2, minus 6, all those other x squareds that I threw at you after I said the answer might be x squared. Okay, so that's where that plus c would go, right? It goes at the end. It could represent a number. The question is, how do you find c? We're going to talk about how you would go ahead and find c as well. All right. Okay. This variable of integration is important. We're going to talk about that a little later on. This is the integral sign. This concept of finding an antiderivative is known as integration. The process of finding an integral or finding an antiderivative is to integrate. Okay, we're going to integrate. All right. So those are some of the terms that you're going to hear me say throughout the video here. Okay. All right. So let's get started. Now, to get started here, we need some rules, right? We don't know any rules for integration. We know a lot of rules for differentiation, but we don't know any for integration. Okay. We need to know how we go backward. So we're going to start with the power rule. Okay. We're going to start with the power rule. Now, you have a little bit of an idea how the power rule might work. For derivatives, you subtract 1 from the power. So the integral, you're going to have to go backward. You're going to have to add 1 to the power, right? Okay, but it's a little more complicated than that. So let's show you what we have. So here's the power rule for integration. The integral of x to the n power, n is a number with respect to x, is x to the n plus 1. I'm sure that makes some sense. Okay, add 1 to the power, divided by what you get, n plus 1. So it's x to the n plus 1 divided by the power that you get. All right, that's what we're going to do. Okay, so if I want to find the integral of x to the 7th dx, or the antiderivative, all I'm going to do is I'm going to add 1 to the power, divide by what I get, and then I got to stick a plus c on because it's possible there could be a number here. So my answer here would be x to the 8 over 8 plus c, and it's done. All right. So now, let's say you got this answer and you're like, wow, I'd really like to know if it's right. Well, you can figure out if it's right as long as you understand what's happening. You are finding the antiderivative. You are going backward from this to this. So you're going backward from, let's say, f prime, doesn't have to be f prime, back to f. So to go forward, if you find the derivative of x to the 8 over 8, the question is, what would you get? Well, I mean, you can do it. You might even be able to do it in your head at this point. You're going to get x to the 7. So then this answer must be right. Okay? You can check all of these to make sure they're correct because you already know how to go the other direction. All right, so this is like being back at the beginning of derivatives where you only know a certain set of rules that you can work with. Okay, let's try to integrate the third root of x with respect to x. All right, so to do this, we're going to have to change the third root to x to the 1/3, make it a power. And then we're going to add 1 to the power, divide by what we get. So it's 1/3 plus 1 on the bottom, and then stick a plus c on it. So 1/3 plus 1, that's 4/3. So that's x to the 4/3 over 4/3 plus c. You cannot leave a complex fraction. So we're going to keep this, change this to multiplication, flip over that fraction. It becomes 3x to the 4/3 over 4 plus c. Okay? And most of the time, you're going to skip to this final step. You're not going to write this thing here with this fraction underneath. You're going to skip right to here where you flip it over. All right? And again, if you derive this, you better get back to x to the 1/3. Okay. Let's try the integral of 1 over x squared dx. Again, I don't have a rule for this. The only rule I have is for a power, but the power has to be in the numerator. All right, so I'm going to have to rewrite this as x to the minus 2. Bring that up, and then I'm going to add 1 to the power. Divide by what I get. So that's x to the negative 1 over negative 1. I'm not going to leave the negative exponent up there, so I'm going to write negative 1 over x plus c, and that's my answer. Okay, let's try to integrate 5 with respect to x. It's a little more tricky. Now remember, think about it. This is the answer for whatever you derive. Whatever you derive over here, that's the answer. So then the answer must be 5x plus c. Okay? All right? And then this variable of integration, we're going to talk about it again. We're going to talk about it on the next slide, I think, in much more detail. Why that's there. Why do we care that this is there? It's there for an important reason. All right. So far, so good. Okay, now let's talk about some other rules. Let's say I asked you to integrate 4x to the 6th minus 2x plus 1. All right, so now we have some rules for derivatives. If I wanted you to derive this, well, you just do them all separately, right? Leave the 4 out of it and derive the x to the 6th. Leave the negative 2 out of it, derive the x, and then just derive the 1 because they're added and subtracted. Integration works the same way. So this can be split up into 3 separate integrals if you want. Now, normally we don't write 3 separate integrals. You can, though. So we'll do it the first time just so that you can see it. We are allowed to do this. And then we can do them all separately. So to do this, again, you just leave the 4 out of it, just like you would in for derivatives. Leave the 4 out. The derivative of x to the 6th, I'm going to add 1 to the power, divide by what I get. Minus, leave the 2 out. The derivative of x, the integral of x, not the derivative. The integral of x, I'm going to add 1 to the power. Well, there's a 1 there, so now it's 2, and divide by 2. Plus, the integral of 1 with respect to x. Now again, whose derivative is 1? X. And then I need a plus c on it because there could be a number at the end. So I can clean this up a little bit. I get 4x to the 7 over 7 minus x squared plus x plus c. Some people ask, a lot of the times they say, well, do I have to write this is equal to f of x? No, I would not. And the only reason I would not right now is because I don't know what function this represents. This thing could represent f triple prime for all I know, and you just found f double prime. So we don't write it unless we're sure that that's what it would represent. Okay, that's the rule of thumb. All right, so we're not going to write that is equal to that. Okay, let's try this next one over here. X minus 5 times 3x plus 2. These are multiplied. So how do I deal with multiplication if I'm doing integration? Well, I know how to deal with it if it's differentiation. It's the product rule. But I don't know how to deal with it for integration. And for right now, you're not going to know how to deal with it for integration. Okay? I'm not going to show you how to integrate a product, both of them in terms of x. It's a little more complicated than, what the product rule was. So what we're going to have to do is we're going to have to go back to where we first started. We're going to have to multiply this out. That's the only way you're going to be able to integrate this thing. You can't integrate it yet until it's multiplied out. So you get 3x squared plus 2x minus 15x minus 10. And then I'll combine these like terms before I do anything. I have 3x squared minus 13x minus 10. And now I'm going to integrate. Okay, they're subtracted, so I could just integrate them all separately. I'm going to do it in one shot. So 3, bring the 3 down, the integral of x squared, add 1 to the power, divide by what I get. Minus, leave the 13 out, add 1 to the power, divide by what I get. The integral of 10, 10x, plus c. I can cross those out if I want. I get x cubed minus 13x squared over 2 minus 10x plus c. There's my answer. Okay, now let's take a look at this one. The integral of 6 dt. So I changed the variable of integration, right? All the variables of integration so far have been dx, all the way across the board. When I integrated on the last slide, I integrated 5 with respect to x. And we said, oh, that's 5x plus c. So if I ask you to integrate 6 with respect to t, hopefully you're thinking, well, first thing, hopefully you're not thinking this. That's wrong. It's not 6x plus c. Absolutely not. Because x is not the variable of integration anymore. The variable of integration is t. So the answer to the integral of 6 dt is 6t plus c. So now you can understand why this needs to be there and why it's so important. It's telling you which variable the rules apply to. And for an example like this or like that, where you don't have any other variable in the problem other than the variable of integration, How would you know what variable to write in your answer if you never knew what variable was there to start with? So, for example, if I ask you to integrate 7, how are you supposed to do that? You don't know what variable to write down next to your answer. Okay? So this is improper notation. You cannot write that. You must have a variable of integration. All right? So that's what this variable of integration does. That's why it's so important. Okay, and finally, we have a blank example. So we're going to make one up. I know you folks are really excited. So here's what we're going to do. We're going to deal with this plus c thing here. So let's say f prime of x was equal to, we'll make it simple, 2x. And there's an initial condition f of 3 is equal to 4. And now I want you to find for me f of x. Well, I know what f prime is. I want to know what f of x is. So I have to go backward one step. To go backward from f prime back to f, I need to find the antiderivative. So to find f of x, I'm going to have to integrate 2x with respect to x. So the integral of 2x is just leave the 2 out, add 1 to the power, divide by what I get, stick a plus c on it. So I get x squared plus c. So now I know f of x is equal to x squared plus c. Okay? But I'm also telling you that f of 3 is equal to 4. So 3 comma 4 is a point on f of x. So if I know x is 3 and y is 4, then I could plug them into this equation and figure out what c would be, right? So I could write 4 equals 3 squared plus c. That means c is negative 5, and that means f of x must be x squared minus 5. And that's the correct answer. Okay? So to figure out the value of c, you need to know a point on that function that you're looking for, because you can use it to then find or determine that value of c to determine which function you're actually on. All right? So this initial condition is important here. Otherwise, you could never find c. That was the case in all these, right? I never gave you a point, so how the heck are you supposed to figure out what c would be? Okay? All right. Final thing. We're going to reverse all the trig derivatives. These are a little bit tricky, I guess. So the integral of sine of x dx. So now again, the question is, whose derivative is sine? Now you might be thinking, oh, it's cosine. But what's the derivative of cosine? The derivative of cosine is minus sine. No, I just want to get sine. So I'm going to have to stick a negative in front of here. So now if I derive negative cosine, oh, the two negatives knock each other out and give me sine. That's the integral of sine, minus cosine. The integral of cosine, whose derivative is cosine? Well, just sine. The derivative of sine is cosine. That's the answer. Whose derivative is secant x tan x? Well, that's just secant. The derivative of secant is secant tan. Correct. What's the integral of secant squared? Tangent. The derivative of tangent is secant squared. Whose derivative is cosecant x cotangent x? Well, the derivative of cosecant x is close. The derivative of cosecant x is minus cosecant x cotangent x, but there's no negative here, so I got to stick the negative there. So the derivative of negative cosecant x would be cosecant x cotangent x, because the negative from this derivative would knock out that negative. And the integral of cosecant squared is minus cotangent. So these are a bunch of rules. Do you have to memorize them? Not necessarily. If you understand how they work, you really don't have to memorize them. You just need to know, hey, the integral of secant squared, whose derivative is secant squared? Tangent. That's the answer. Okay, Let's integrate cosine theta minus 4 cosecant squared theta plus 11 d theta. The integral of cosine theta, sine theta, minus, leave the 4 out of it, the integral of cosecant squared minus cotangent, plus, now you got to be a little careful, the integral of 11 d theta. It is not 11x. It's 11 theta. Theta is the variable. Plus c. These two negatives knock each other out. I have sine theta plus 4 cotan theta plus 11 theta plus c. That's my answer. Okay? And that's it. That's how you go backward. We already know how to go forward, which puts us at a huge advantage. And as always, thanks for clicking.